All right, 4-2, day 2.
I'll definitely. Okay. Let me get my calculator on. That's a wrestler.
I didn't make the test.
Taco, shut up.
Yeah, I gotta close that.
Yeah, it might be open. Close it like that wall.
What's it like, what?
The wall.
The wall? Oh, yeah. I'll build the wall right there. Let Mexicans allowed in here for exit right here.
Grab the line.
That's illegal.
Actually, it's an American citizen. I hope not.
Amber, what you waiting for?
Yesterday?
Yesterday we were looking at a very good song, and people were talking, and literally people looked that night. Whole bunch of started laughing.
Okay. 82% of the people,
Where you just examples, right?
yes.
How many examples?
I don't know. 3 maybe?
They're all
Pretty much. Okay, 82% of the people that win the lottery say they would buy a car. You are going to ask 5 people that win the lottery, would you buy a car? And we're going to let X represent the people that say, yes, I would buy a car. Okay. So it says to make the probability distribution. That means make a table of values for all possible X outcomes and the corresponding probabilities. And I do have a little bit of a streamlined way to do this, so we don't have to go back in and type over it a bunch of times using those lists, and I'll teach you that in this first example. So if X is going to be the number of people that say, yes, I'm going to buy a car if I win the lottery, what values can X take on? How big is this table going to be? So what's the least number of people that would say, yes, I would buy a car? 0. What's the most? All the way through? 5. So our X values can take on numbers between 0 and 5, including. Nathan, it would be best if you were paying attention.
Yeah.
I don't know why I talked to you. I should just let you, you are going to fail. I'm just going to let it be.
No, I'm playing Amber right now.
Okay, so we're looking for the probability that 0 people would buy a car, 1 person, 2 people, 3 people, 4 people, 5 people. Okay, we've got our formula for this. With that NCR, what's the N for this problem? How many trials are we doing? 5. Then we use that NCR button, and we put our X number here. I'm just going to use X for now, because that's where we keep resubstituting in. Then it gets multiplied by our p-value. What's the probability of success on each trial? Where do I get that from? The 82%, so 0.82. And that gets raised to the X. Then that gets multiplied by the the Q value. What's the Q value equal to? 0.18, because it's the rest of the 100% here from the probability of success. And then that gets raised to the N minus X, and our N is 5. And the way I had you do it yesterday when you had to find more than one probability is you re-entered the line and you went back in and typed over the 3 X values. Okay? We can make the calculator do all of this for us using the lists. So what we're going to do is put X values into list 1, and then in the second list, it's going to be our formula. So let's practice this so you can see what I'm talking about. So, I'll turn this on. I know. So go ahead, stay at edit, clear out, and then you want 0 through 5, so I'm just going to delete the ones that I've got here. Okay, and I'll wait for everybody to get 0 through 5 in list 1, then I'll show you how we can get it to do all 5 of those just like that, instead of us typing it in 6 times and hitting enter. It'll go a little quicker than yesterday. Is everybody ready? Okay, go over to the top of list 2, and we're going to type in exactly what we wrote down here, except instead of putting in X, where do we have all of our X's stored at? L1. So wherever we have an X, we're just going to put L1. And then it'll do that for us.
Why did we do that yesterday?
Just so you would learn the process. So, we're going to go ahead, we got to put in the 5.
Wait, what did you just do?
5 first. Okay, you can turn them up with. I'll show you later. Then go grab the NCR,
Wait, what did I just miss?
put in the 5. I'm up on the top of list 2, I'm up on the name. Is that where you're at? On the top. 5. Then go grab NCR. Then we're going to tell it, instead of X, we're going to say take every number in list 1. Then multiply by
I don't think it's...
0.82. Raised to the, instead of X, we're putting in L1. Multiply that by 0.18 raised. Now we do have to do 5 minus L1. That's going to have to be in parentheses for it to know that it's an exponent. So in parentheses, you're going to put in 5 minus L1. And when we hit enter, it's going to do all 6 of those calculations for us. A little quicker than yesterday.
No.
Anybody match mine? Did I type something wrong?
No, I
Oh, you got mine? Oh, it still worked? Okay. Oh. We're going to do another one again at the end. What? The first probability then, see the e to the negative 4th on the end of that line down here? E to the negative 4th? That means we're going to back it up 4 places. So it'd be 0.00019. Second one's 0.0043. 0.0392. 0.1786. And 0.4069. Oh, there's still another one. And then 0.3707. Okay? Now to find the mean, the variance, and standard deviation, remember we had shortcuts for this. So for binomial, I wouldn't bother doing all that x times p and some of the, we got shortcuts. The shortcut for the mean from yesterday, do you remember what it was? N times p, nice. So our n was 5, and our p was 0.82. If you went through and did it with the long formulas, you'd still get the same answers. You're just doing a lot more work than you have to do. So, what is that? 4.1. The variance is n times p times q. Anybody crank through that? Sounds about right. And then how do you get that standard deviation again? Square root that answer.
Is that 5 or 3?
That? 5? That's a 3.
Yeah.
What's this one?
0.859.
Okay. Using this table now, we took the time to generate, I'm going to ask you some probability questions. So based on this experiment, can you tell me the probability that no more than 2 people would buy a car? So we've got to take that statement and turn it into, well, what X values am I really looking at having here? What does it mean to say no more than 2 people, according to this chart? 2 or less. So it's this question is asking for what's the probability that no people buy a car, or 1 person, or 2 people. So how do I get that total probability? Considering I used the word or, I just got to add those 3 probabilities together. So it'll be 0.0019, 00019, 0043, and the 0392. So less than or equal to 2 is no more than 2. And, anyway?
0.0435.
Sounds good. I'll change my question. Same situation. What's the probability that at least 2 people buy a car? Okay, so now it's interpreting. What does at least 2 mean to you? 2 or more. So that means X is greater than or equal to 2. So that means we could add the 2, 3, 4, and 5 probabilities together. Or what else could we do, knowing that they all add up to 1?
Subtract 0 and 1 minus.
Add these two together and subtract from 1? It doesn't matter to me which way you like. To me, I would do the shortest amount of work, which would be add these 2 and subtract from 1. But I'll write them both down, because there's 2 ways to do it. So greater than or equal to 2 would be adding 0.039 to plus 0.1786 plus 0.4069 plus 0.3707, or you could do 1 minus the 2 that we're not using, 0.001019 plus 0.0043. Both will give you the correct answer. Anybody? 9955. And then the last thing we want to do is graph that distribution. In a histogram. Oh, you'll survive. So our X values will go along the bottom, the number of people that would buy a car. So that's 0, 1, 2, 3, 4, 5. And then we've got our probabilities. And our highest probability in that table was 0.40. So I'll go by 0.1, 0.2, 0.3, 0.4. And now we'll just center the bars over those outcomes. So for 0, it was it was minimal, 0.00019. It's hard to even make a box that's that minimal. It's really small. The next one is 0.0043. I mean, it's bigger than this one, and I really shouldn't be getting a little bigger, but I'm gonna have to draw it just a smidge bigger. The next one's really close to 4%, so that's almost halfway, not quite to the 1. So about there. Now we're up at 18% for the next one, so that's way up here. Now we're getting somewhere. The 4 is up at 40%. And then the 5's back at about 37%. Okay, what shape does that distribution have? You remember the names of the shapes? Skewed left, it's where the tail is. This is skewed left. And that's going to happen when our probability of success was 82%, so we had a really high probability of success, so we would expect more successes than we would fewer successes. If we have a really small probability of success, we would expect the higher bars to be down here on the low end, and then the low bars over here. So we're going to talk about, I'll write it down anyway, when something's going to be skewed left, when it's going to be skewed right, and when it's going to be symmetrical. No, we're not done yet.
Oh, back up?
Yeah, I'm getting close.
We are getting close. Okay, so the shape. Of a binomial distribution. We just saw that if the probability of success is over 0.5, your graph is going to be skewed left. If the probability of success is under 0.5, it's going to be that way, skewed right. And what's going to happen when the probability equals 0.5? What shape is it going to have? Do you remember? Symmetrical. Not really that weird. Good. I have 3 examples today.
So the last two
So,
are long as the first one.
Kind of. No, not really. We're not making the table. We're not writing it down anyway. Okay, 22% of third graders have a cell phone. I made that up. That was my educated guess.
You can turn the TV off now if you want.
Yes, I will.
Thank you. I do.
I'll have to turn it back on because I know you're not going to be able to make the table again by yourself, but give you a little break. 22% of third graders have a cell phone, according to Mrs. Schwartz, but I don't really know what it is. You randomly ask 7 third graders,
If they want to pack smokes.
do you have a cell phone? We're going to let X represent the kids that say yes. I'm going to write down my 3 probability questions and then you're going to answer them. So the first probability question says, find the probability that 3 have a cell phone. Second question. Find the probability.
How many lines?
That's it, just an answer's going down. 1 line for each. That at least 3 do. And the last question. Find the probability that no more than 2 do. Okay. So we need to see these probabilities for all of this thing. So you would want to generate the table using the list like I showed you at the beginning of class. So see if you can do that on your own without my guidance. Can you generate the probability table on here? probably can't, 'cause I think he was gone. So what's the first thing we do?
Put them in the list.
How many numbers do you need in a list? 0 through 7. So I'm gonna add 6 and 7 to the list that I have. 6, 7. And on a test and homework, I would like to see, because we're going to be having different formulas, I want to know what formula gave you all of these probabilities. So you'd only have to write it down once for the chunk of problems. And the problem, it doesn't matter, I'll put it right in here. How's that formula work again? What do we need first? The 7. C, and then we just write down X, because it's going to switch every time. We're going to do all the X's. Times. What comes next? 0.22 raised to the X times 7/8 raised to the, what is N? 7 minus X. And what is X going to be when we type it in? L1, because all of our X's are in 1. You got it. Okay, so go ahead and execute. So make sure you're up on L2's name. We're going to type in exactly what we just wrote down. 7 NCR L1 times 0.22 raised to the L1 times 0.78 raised to the 7 minus L1. This will have all of your probabilities. Now it's just up to you to pick which ones apply to my question. So, for the first question, I said, what's the probability that 3 people have a cell phone? Did everybody get 0.137, maybe 138? Yes? Success? First 3, I got 0.137, what would be 80? Okay. Find the probability that at least 3 do. What does that mean? 3 or more. So this one you can do with a 1 minus. I think it would be quicker. What would I 1 minus? Which ones do I want to subtract off?
0, 1, and 2.
0, 1, and 2. That would be a little quicker than adding up 3, 4, 5, 6, and 7. You could either add 5 together or do 1 minus the bottom 3. Your choice. Or if you want to add all those other ones up, add the rest. I don't want to add too long.
I got
0.184? Sounds good. And then what do you do to get no more than 2? What's no more than 2 mean to you?
2 or less.
2 or less.
Yeah.
You're right. 2 or less. So that's X is less than or equal to 2. So that's those bottom 3 probabilities we've got right there. 0, 1, and 2. So it's just going to be 1 minus this answer again? I think so. 816? Okay, last question's going to take a little bit of thinking on your part.
How much room goes in?
Less. We only have one question. I'm going to squeeze it in right down here. Okay, you're gonna guess on a 10-question multiple choice test. It's written in Chinese, so you can't even read it. Each question has A through D.
But if it's Chinese, what do they have? American
Oh.
letters?
They're giving us a chance. I don't know the Chinese alphabet. Okay, find the probability of passing the test with at least a 60%. Okay, the only thing that makes this question different than the other ones is I'm not telling you how many successes. You've got to figure out how many successes it takes to get at least a 60%. So if it's 10 questions, how many do I have to get right to pass with at least a 60%? At least a 60%. 7, 8, 9, or 10. So I've got to get 6 or 7 or 8 or 9 or 10. So that's the tricky part, was getting from this to say, well, because X is going to represent the number I get correct. The number correct. And what are my possible options there for the number I can get correct? From what to what? How many questions can I get correct?
5. Or no? 6, 7, 8, 9.
From what to what? Can I overall?
6 to 10.
That's all I'm automatically going to get 6 to 10? I can get anywhere from 0 to 10.
Wait.
So if I was, I'm not asking you to make the whole table. We are going to make the whole table. We're not going to write it down. X can take on values from 0 through however many trials. We're looking for the probability that I get at least 6 correct. So 6, 7, 8, 9, 10. So probability that X is greater than or equal to 6. So we want to make the probability distribution on your calculator. And you told me we were going to add just the ones from 6, 7, 8, 9, and 10 together. Well, let's be clever with our table here. And you can thank Keeker for this one, because I made him make the whole table. Because Keeker said, well, if we're only adding 6, 7, 8, 9, and 10, and we know how to get the calculator to add a list together, let's just put in the first list, 6, 7, 8, 9, 10, because those are the only ones I want anyway. I don't care about the other ones, so why generate them? Make sense? So for list 1, all we really want in here is 6, 7, 8, 9, and 10, because those are the ones we're going to add together. Six, 7, 8, 9, and 10. And if we write down the formula, how's that formula going to start again? How many trials are we doing? 10, C, X, and X is going to be 6, 7, 8, 9, 10. What's our P? Careful, read that again. Point what? I'm answering a question. What's the probability I get the question correct?
No.
0.25. Don't automatic, that 60% gave us our X value. It's not giving us the probability of success. See how tricky this was?
Oh, yeah.
A through D is giving us our probability of success. Okay, so we got, let's see, how am I going to finish this? 0.25 raised to the X times what? 0.75 raised to the 10 minus X. And again, we only want to plug in 6, 7, 8, 9, 10, so that's all we put in here. Go to the top. 10. List. And now that those are all the numbers I want to add together, you can go to that list math and sum those up without actually having to type them all in yourself with a plus sign in between them all. So if you had generated the whole list from 0 to 10, you would have had to manually write all these down and then add. Doable, but extra work that we didn't need to do. So Keeker was working smarter, not harder there on that one. So we'll quit, go to lists, over to math, sum up everything in L2, and there's our probability. Only about a 2% chance you're going to pass that test in Chinese by guessing. Okay.
What was the third option?
So your homework. It's on page 174. Okay, it's 7 through 12, parts B and C. We did part A yesterday, and 16, but I did change almost all of the part C, so I want to make sure everybody's book has the right change to part C question.
Oh, I see, yes.
Yeah.
That people, yeah, otherwise every single one of them was 1 minus the answer from B. 1 minus A was stupid. So, just to make you think a little bit more, I changed all of the part C's. So let's make sure everybody's book has those changes. So go to page 174.
Or your part B and C.
Just change in part C. So part C only is going to get changed.
More than 3?
We only did A yesterday unless you copied the answers to B and C too.
That'd be why.
That'd be why, yeah. You pay attention. Okay. 8C, the 5 should be changed to 4. 9 should completely change to more than 3. 10 is more than 5. More than 5. 11 is at most 3. And 12 is at most 20. Okay. Yeah. You need,
Here for the test Monday, but I need Tuesday.
stay in the
Tuesday.
room. Go ahead, just,
Like, we have to change something.